Welcome to the first actual programming video. We've had two videos that just gave us a design for our event system. So today we're going to actually implement the event module and event handler. We're not going to worry about objects or object listeners or anything else, because that's not part of the actual event system. That's just how it interacts with other things. So without further ado, we'll go. Get ready, get started, whatever. So first thing we're going to do is create our core package, in which nothing in here should be modified after it's already been created and designed properly, unless we do need to modify our design to account for our new functionality. So first thing we're going to do is create our event handler, and this is just a class, and we'll do documentation as we make things. So handles event dispatching and subscriptions to events. And that's what our event handler does. So now we'll create a new class that's our event module. And that's going to be an abstract module. And this should not be in that package. It should be in the module package, which is going to be, it's essentially going to be all the modules, and modules serve as configurations, or the configuration for a specific system. So now that we have the generic creation of class out of the way, let me comment this really quick. Serves as the configuration for the entire event system. So now, we discussed in the design video for this how it needs to interact with other things. So we had a few different things. It needed to be able to register and unregister subscriptions to events, and it needed to be able to dispatch events to those subscribed event listeners. So to do this, we'll just start off by creating methods. So we're gonna just register we'll just call it register listener. Object listener. And we're not gonna worry about the implementation yet. We're just gonna lay everything out and then implement it. Registers an event listener. Oops, silly me, forgot void. And this is just going to be unregistered. And then we also need to create one that dispatches. Let's add our documentation. Notice we're dealing with these all as objects, so we don't have to specify a type and have another dependency. I believe I went over that in the design video, but just to make clear. Also, we want to be able to dispatch things, but we will have other events that need to have a delayed dispatch. So we'll take that idea and do it now, and begin implementing it now. So we'll have a long delay Alright, so now we have all our methods. Now we need to actually find a way to implement this. And to do this, the easiest way would be to use Guava's library, which we will be using throughout the entire application, and use their event bus, which is a really useful class that handles all of this behavior for us. So we're just going to go private final event bus. Now, instead of creating an actual dependency here and keeping it managed here, what we're going to do is use injection or dependency injection to deal with this dependency. So the first thing we need to do is create we need to create an inject annotation, or add it rather, and then because we might be using an event bus elsewhere in the application, we're going to need to create a named annotation, or use that named annotation, and we're going to have a convention of having the class name and then the actual variable name, so we don't have any collisions. So we're just going to copy this for later, which is right now actually. So we're going to bind the event bus class with annotate with the annotation of names.named, and then to an instance. We'll worry about that in a second. I just need to import this. Oh, silly me. And we're going to bind this to an instance. We need to bind it to an instance because the event bus class itself, it does not behave as we would like. The way we want it to behave is that whenever any thread dispatches a task or dispatches an event, it needs, well, whenever it posts an event, what needs to happen is that all of the listeners that are listening need to execute on the same thread, no matter what type of event or anything. We need it to all execute on the exact same thread. So that way we don't have to worry about multiple threads mutating state or just doing other things like reading state or anything like that. So we don't have to worry about that. So we're just going to have it all execute on the same thread, but we'll be able to post events from any thread and not have to worry about it. So we're going to create a new asynchronous event bus. And this is another class provided in the Guava library. And that takes an executor. So we're going to do a new single thread executor because we only want a single thread. So now we've dealt with this. We just have our general event bus. Our delayed thing, we can use a scheduled executor service, which I'd like to remind everybody is an interface, not an implementation. So you can provide your own if you really like to change it, or we need to change it later on, which I don't think we will, but we might. And because we might need to change it, and it's a dependency, we're going to use an event. Ooh, how did I miss that? Anyway. probably type things properly and copy and paste them properly as well. So it's going to be schedule So now we have both things provided to us, and now we are going to implement it. So we're going to bus.register listener. Copy this for later. We're going to need to make this final, and we're going to go scheduler.schedule. Oops. Alright, so this class is done. Oh, we also have to bind that. So let's go back in here, copy this, because we don't want to make a typo. Import this. And we're just going to use a new single-threaded scheduled executor here. So I don't think we'll need it, but if we do, we can always change it just with one line of code. So now we have everything done, we need to actually test it. So we're going to create a new package, org.mu.test.module. And what this is going to do is this is going to that module test. This is going to test all aspects of the event system. And we're going to have two different types of tests. We're going to have one that tests a manually just created event handler, and we're going to have one that tests the dependency injector one. This way, if we end up having an issue with our dependency injected one, we can figure that out instantly, because we'll have this succeeding and this failing. So if we ever want to change this, we'll always have this test to ensure that nothing we did, or to just double check that nothing we did was in the event handler, and nothing in the event handler that we did was actually the cause of the issue, and that it was just what we did to the configuration. So what we're going to actually need to do is create an event handler by hand, just like you would without dependency injection. And we're going to go new. We're going to copy this actually. This way we have it exactly as we need it. And then this one as well. So now we have our event handler. We're going to make a method that just tests both of these, that way they're identical. And because we're only going to be using one class right here, because our event system is so nicely done, we're just going to go event handler equals juice dot create injector new event. Oops. So now what this does is it creates a juice injector, which there's only going to be one of in our actual application using event module, and in our actual application it's going to have all the modules. Then it gets an instance of event handler class. So now we need to actually create the test, and we're going to have two aspects that we're going to test. We're going to test to make sure that our interfacing with the event bus works properly, and we're going to test the behavior, like our contract that we had, that it needs to execute all on the same thread, which is the whole reasoning we came up with this part of, or this way to pass in the this is why we need to pass this in instead of just creating a new event bus. So what we're gonna do here is we're gonna create two methods. We're gonna go test methods, which is the test, and then test thread execution, and we're gonna actually pass some handlers. So once we got this done, we're gonna do the methods one first. So we're gonna create a new listener object, and if you notice, we can use an object and override it right here, and we don't need to do anything special or fancy to do it. We just need to put the subscribe annotation, and then on whatever method we want to use for the listener. And we're going to have a flag that we set, and we're going to have an object called test object. And we're just going to go flag set true. And then we'll just create a little class test object over here. This way we can reuse it for our other method. And I don't think we can in Java do that. So this will be executed on multiple threads, so we need to synchronize it. And I'll actually make that public. So we'll just do public final, and then atomic boolean. And we don't need to specify what the initial value is, but we'll do it just to be explicit. This way, when you're looking over the code or whatever, you can just say, oh, hey, that starts off as false, instead of just having to hover over it and see how it works. You can see our explicit assumptions, see our assumptions explicitly. So now we'll register the handler, or the listener. Now we need to dispatch a test object. But we'll need to test that test object later on, so we'll just go now, because it's executing on another thread and we don't really have a way to ensure that it's been executed, so because we don't have a callback function, because we won't really need it for anything but testing, what we're going to end up having to do is sleep. We're going to have to sleep for a short time to ensure that this has been dispatched and this has been executed before we test it. So after we've done that, we're going to want to unregister the listener, and we're going to want to assert that the flag is set to true. So we're going to go test.flag.get, and now we can run our test and it should work. It does. So we're good to go on this test, but we need to do documentation right now. Alright, so now we can just, this is going to be similar, but still different. So we can just copy and paste it and just change it how we need it. Change it to behave however we'd like. So we're going to want to run this twice to get what thread it's on and make sure it's the same. So, hold up, flag. If the flag, if it's set to true, which it starts off as false, then we'll do that. But then otherwise we need to do that. Then in this one we'll set it to true. But what we need to do is we need to figure out some way to identify a thread. So we can't use a thread name because that's not always, I don't think it's guaranteed to be unique. But what we can use is the thread's ID, which is guaranteed to be unique and non-negative, I believe. I think it has to be positive. So we're going to create one that starts as negative so that we can ensure that it's actually been run. And then we're going to create another one so that we can compare it. So then we're going to go o.thread ID 2 because this is going to be the second one that's executed. Thread then this is just the other variable. Then we need to change our test as well. We also need to make sure that it's actually been run. So we can actually, what we can do is test one of them, and if then they're not the same, it'll fail. So we need to assert that this is true and this is true. Test, get 1, and it's not equal to 1, and that should be true. We have a problem here. We need to execute this twice, but we need to do it on a separate thread. So what we can do is we're going to end up having to put it on a new thread, so we're going to make these final. And then we can dispatch that there, then we can create a new future task. And we don't care about the type, so we'll just set to void. Import these. We'll leave it as null because we do not care. We'll call that, oops. New thread. So it's going to start a new thread that executes this. Then, oh, we need to wait for it. We can't remove this because this is still executing. Even though we're waiting for this to execute, we don't have a guarantee that this will execute before this. And this won't be a problem when we're working with multiple players, because the ordering of packets between different players doesn't matter. It's only the same player's packets that matter. Like a player has to eat their food. Like if they hit eat food before attack, you don't want it to be attack before eat food, but between multiple players it doesn't matter at all, so we can get away with this. So we have our comments. Let's just test this, and it works. So we've finished everything, I believe. I don't think I've forgotten any comments or functionality. So I'll see you guys in the next design video.